What's going on? Today we're given a pcap file. The pcap file represents the traffic capture taken from a network where there's a host called, um, where is the host? Yeah, the host is a computer, actually. Let me click the filter first. Okay, here we go. So let's go up. So we have a host on the domain controller, DC Rock Mountain. This host is infected with a malware called URsniff. Now, if you don't know what is URsniff, you can just take a look at URsniff, which is banking Trojan. Okay, normally URsniff is delivered through spam campaigns or email campaigns. You can read more about this malware if you type URsniff malware. So let's take a look at the malware, how it works, and then we will analyze the pcap file that was captured at the time of the infection to just Europe. Okay, to build just a chain of events of how the infection occurred, what are the indicators of compromise, and see some addresses and domain names related to the command and control center of this malware. So as a summary, as you can see, URsniff malware, also known as Cozy, is one of the most widely spread banking Trojan. The malware source code was leaked 2015. Okay. URsniff is effectively delivered through malicious spam campaigns. Spam campaigns is a Microsoft Office document that instructs the user to enable macro. So it is delivered through, Office documents. And once you click on enable content, there will be some VBA Visual Basic script. I would assume that it will execute malicious commands and perform the intended objectives of the malware. So one of the new campaigns of URsniff is taking advantage of NAPS, entity, okay, behavior steals, computer data, computer name, user credentials, communicate, CNC servers, download additional malware components, executes backdoor commands from a remote malicious user to connect, etc. You can read the analysis here, but how about we analyze it from the perspective of a blue teamer? So if you're a blue teamer and you're analyzing a pcap file or IDS logs, firewall logs, you need to be familiar with indicators of compromise of this malware. So for example, if you are examining not only a pcap file, you could be examining live traffic, live monitoring of network traffic in a specified client network, and you noticed something weird happening. You should be able to pinpoint what are the possible malicious addresses that are being communicated with in the network. So we will examine some of the indicators of compromise of this malware. So you as a blue teamer can, during real-time analysis monitoring or during an offline analysis, if you're doing incident response, you will be able to pin down these indicators of compromise and spot the addresses and command and control centers used in this malware. So as always, we're given a pcap file. Okay, so the first thing, all of the malwares are delivered through HTTP, right? Browsing. So if we type HTTP, filter for HTTP traffic, and let's examine. So we'll go up. Let's see here. So let's expand this more. Destination. Okay, so we have here the source, destination. This is the host. Okay, let's take this to the left. All right. So I have here the source, I have here the destination. But I think they are kinda reversed. Let me check on the columns. There's something wrong here. So we go to column. If you want to customize the columns, you can go to columns, and here you have source address, destination address, host, destination address unresolved. Okay. I think I'm gonna need to reopen this. I didn't like this view. Okay. So one more time. All right, so this looks a bit better. So as you can see here, we have the desktop that is infected in this case, having some traffic to different IP addresses, right? So if we type for filter for HTTP to see how the infection happened, let's see here. So as you can see, our spot here is the desktop nb72 tzawalkmountain.com, which is part of the domain controller. Now, as you can see here, if we examine the traffic pattern, of course, you can take this on the right to see the IP addresses first, and this is the name resolution of the IP addresses, which are the destinations. So if we scroll down on the IP address, we see a repeated pattern, repeated traffic to this IP address. As you can see here, this is 2, and these are MX14. Okay, nothing malicious here. Let's go down. Let's filter for this IP address and put and destination.ip 209.141.51196. IP.destination. So we have 2, as you can see here. Okay. Let's follow the TCP stream, see what's happening in here. As you can see, if you look at the TCP stream, you have multiple requests. With this is the first one, and as you can see, when they requested /lk9tdz, this is the return response, and they requested files/1.bin, which could be the malicious file or the malicious binary, and then the response was kinda messy. Yes, so this is the response, as you can see here, and this means one thing, that the first infection happened when the host or the target host navigated to this address and retrieved this file. So they clicked on the URL and retrieved the first binary, which is the first indicator of compromise, as you can see here. So you can take a note, taking these 2 addresses or these 2 URLs, right? As you can see here, this is some of the content of this file. This program cannot be run in DOS mode. We can later export this file. So we can just type row and save it. Save as, give it a name, 1.bin. Let's see this one. Okay. So let's get back now to the HTTP traffic. So now you take in your notes, you take a note that this is the IP, which is the first indication of compromise. So if you go down, let's see here. These are okay. Let's go down. See, we have a request made to this IP address, and the domain name is great wall firewall.xyz. As you can see, the HTTP request, and there was another request. And with every request, as you can see, there is return back. So let's examine the first request to understand how the chain of requests, what do they contain? Postfix. Let's see here. Go down. This seems to be base64 string, as you can see. Base64 with backslashes, underscores. The request was made to, as you can see, to get a file with the extension of YML, right? So, and this was the response. Not sure what this is all about, but this is definitely one of the indicators of compromise, as you can see. So what we can do here, we can just file, export objects, HTTP. So let's see what we have here. So we have, this is the YML file retrieved from the Great Wall Firewall. And also we have another file called g.yml. In order to examine them, we have to save both. So let's save this one. And let's save this one. So in a separate terminal, ls g.yml. Base64 encoded. Next one. Also base64 encoded. So we can decode them later, but you can put a note to just try to decode the content of this configuration files later. But definitely, they are one of the indicators of compromise of this malware, YML files. So as you can see, first they retrieve the bin file, and then after that, configuration files. Let's get back to the HTTP traffic. Okay. So all of the subsequent traffic are, this is fine. Okay, these are the only HTTP traffic we have. Okay, next let's filter for HTTPS. HTTP and TCP ports equal 443. We don't have. Let's filter only for TCP port equal 443. So here we have the HTTPS traffic. Let's examine the HTTPS traffic, see what we have. Skype, okay. Nothing seems to be here. Dual. Just a normal exchange of traffic. As you can see, the pattern is repeated all the time. There are requests going to Akami, which is, definitely not a malware. If we go down. Oh, here you go. So we have this bollolo3.com. We have many requests going to that domain, and then the response back. Let's examine them by right-clicking on the first request, which is here. Follow TCP stream. And yes, this is HTTPS traffic. We cannot determine the content. But definitely for examination, we can just take the domain name and find out what it is about. Okay, now after we filtered for HTTP traffic, filter for HTTPS traffic, now let's filter for DNS traffic. So in the DNS traffic, let's see if we see something that is out of the ordinary. Work mountain, work mountain. All traffic here are for the domain controller. We see here, if we go down, open DNS resolver. This seems a bit fishy, right? Resolver.OpenDNS. Not sure if the um, domain of the workstation is using this DNS as server to resolve queries. Okay. UDP port equal 51 DNS Okay, let's filter back for HTTP traffic. So until now, we built kinda chain of events, starting from first downloading the malware from this address. And after downloading the malware, as you can see, there was some connections to Great Wall Firewall, and we examined this, where the malware retrieved some configuration files. And right after that, if we continue down the chain of events, we see a request going to this domain name, server1.oniri pictures. Let's examine it. So in this request, there is a compressed file, a RAR file being downloaded, but not found. So there are multiple requests, as you can see, to this domain name. And every request, there is, as you can see, if you go down here to the view, there is a RAR file being requested, a grab32.rar. This one seems like the malware or URsniff malware, after you execute it, right, it downloads subsequent malwares in the form of RAR files. So you can also add this to the indicators of compromise, to your list of indicators of compromise. And let's see here if we can filter for something else. So until now, all of the malicious traffic came from the HTTP protocol, as you can see. This is the first address delivered the first malware, the first infection, and then we have the configuration files came from Great Wall Firewall, and lastly, we have the RAR files, the follow-up malware came from this address. So these are both three IPs and domain names associated with these IP addresses are part of the indicators of compromise. Now, if we go up here, the first request, and examine this one, we see we have the request for the bin file, right? Now, after we built our list of indicators of compromise and we analyzed how the infection happened and what are the CNC addresses, we want to confirm our analysis by just exporting the object. Let's open the file now with hex editor, malware.bin, open with, um, choose an app. No, okay. Less malware. Okay. So this is the hex edit of the file. Now, not every part of this file is an executable, right? Some of it, as you can see on the right, part of the HTTP requests. So if we just remove that part and only leave the part that is related to the executable file and upload that to Wireshark, to VirusTotal. So let's start from here and delete it. Save the file. Put this on desktop. Okay. Let's upload this to Aristotle now. And indeed, as you can see, we received this result, which means that our analysis was correct. And indeed, this is the first malware or the first infection that happened on the machine. So most of the classifications are hinting or pointing towards banking Trojan, as you can see. Sergo, Sergo. Yeah. If we take a look at the community section, we see some analysis done by the community. Let's click on that. The family is Emotet, malicious packer. Okay. All right. So that was about URsniff malware, backing Trojan, and how to analyze it with Wireshark. See you in the next video.